Hello everyone, welcome back to my YouTube channel Geography with Sumona. I am Sumona. In today's video, we will learn about the nature and composition of the atmosphere. So, without wasting any time, let's begin today's lesson. Now, let us understand what the atmosphere is. The atmosphere is a life-giving gaseous envelope that surrounds the Earth. It is mainly made up of different gases along with water vapor and tiny dust particles. The Earth's gravitational force holds this blanket of air around our planet and prevent it from escaping into space. The atmosphere extends hundreds of kilometers above the Earth's surface. Although most of the air is concentrated near the surface, then the question is, why is the atmosphere so important? Because without it, life on Earth would not exist. It provides oxygen for breathing, carbon dioxide for photosynthesis, help regulate the Earth's temperature, protect us from harmful solar radiation, and plays a major role in weather and climate. For example, imagine going outside on a hot summer day without any air around you. We would not be able to breathe. There would be no clouds or rainfall, and the earth temperature would become extremely hot during the day and extremely cold at night. This shows how essential the atmosphere is for life. Now let us discuss the physical properties or nature of the atmosphere. The atmosphere is often called an invisible ocean because, like the ocean, it completely surrounds the earth. Although we cannot see it, we can feel its presence as wind and air pressure. The first property is shielding. The atmosphere acts like a protective shield. It protects living organisms from harmful ultraviolet rays of the sun and burns up most meteors before they reach the Earth's surface. The second property is permeability. The atmosphere is transparent, which means sunlight can pass through it and reach the Earth's surface. The sunlight provides light and heat, making life possible. The third property is dynamics. The atmosphere is always moving and changing. Wind, cloud, rainfall, storms, and other weather phenomena occur because the atmosphere is dynamic. The fourth property is that air is colorless, odorless, and tasteless. Even though we cannot see or smell clean air, it is always around us. Finally, air has mass and exerts pressure. This is known as atmospheric pressure. For example, when we drink juice with a straw, atmospheric pressure helps push the liquid upward. So these physical properties show that although the atmosphere is invisible, it plays a vital role in protecting the earth and supporting life. Now let us learn about the composition of atmosphere. The atmosphere is mainly made up of three components: gases, water vapor, and dust particle or aerosol. Each of these plays an important role in maintaining life and controlling weather and climate. The first component is gases. The atmosphere contains permanent gases such as nitrogen and oxygen, as well as variable gases like carbon dioxide, ozone, and water vapor. These gases are essential for life and different atmospheric processes. The second component is water vapor. It is the gaseous form of water and is responsible for the formation of cloud, rainfall, fog, and many other weather phenomena. Although it is present in a small amount, its role is extremely important. The third component is dust particles and aerosol. These are teeny solid or liquid particles suspended in the air. They act as condensation nuclei. That means condenses around them to form cloud and eventually rainfall. For example, when water vapor cools in the atmosphere, it needs tiny dust particles to form cloud droplet. Without these particles, cloud formation would be much more difficult. Now let us look at the permanent gases present in dry air. These gases remain almost constant in proportion throughout the atmosphere. The most abundant gas is nitrogen, which makes up about 78.08% of the atmosphere. Although we cannot breathe nitrogen directly, it is very important. It helps dilute oxygen, prevent rapid burning, and plays a key role in the nitrogen cycle, which is essential for plant growth. The second most abundant gas is oxygen, which makes up about 20.95% of the atmosphere. Oxygen is essential for the respiration of the human and animals. It also supports combustion. For example, without oxygen, a candle cannot burn and living organism cannot survive. The third major gas is argon, which makes up about 0.93% of the atmosphere. Argon is an inert gas. That means it does not easily react with other substances. Although it has no major role in weather, it is an important part of the atmosphere. Carbon dioxide makes up only about 0.04% of the atmosphere, but it is extremely important. Plants use carbon dioxide during photosynthesis to prepare food, and it also helps keep the earth warm by trapping heat. This is known as greenhouse effect. Besides this, the atmosphere also contains trace amount of gases such as neon, helium, krypton, xenon, hydrogen and ozone. Although their quantities are very small, some of them perform important functions. For example, ozone protects us from the sun's harmful ultraviolet rays. So even though nitrogen and oxygen together make up almost 99% of the atmosphere, every gas, whether present in a large amount or a trace amount, has its own importance in maintaining life on Earth. Now let us discuss the most abundant gas in the atmosphere, that is nitrogen. Nitrogen makes up about 78% of the Earth's atmosphere, making it the largest component of the air. Although we breathe air every day, our body cannot use nitrogen directly. One of the main functions of nitrogen is to dilute oxygen in the atmosphere. If the amount of oxygen were much higher, even a small spark could cause rapid combustion. So nitrogen helps maintain the stability and safety of the atmosphere. Another important role of nitrogen is in the nitrogen cycle. Atmospheric nitrogen is converted into usable forms of soil microorganisms. Plants absorb the nitrogen compound through their roots and use them to make proteins and grow properly. Animals and humans then obtain nitrogen by eating plants or plant-eating animals. For example, farmers often use nitrogen-rich fertilizer because nitrogen is essential for healthy plant growth and higher crop production. So although nitrogen does not directly support respiration like oxygen, it plays a vital role in maintaining atmosphere balance and supporting life through the nitrogen cycle. Now let us discuss the second most abundant gas in the atmosphere, that is oxygen. Oxygen makes up about 21% of the Earth's atmosphere. Although it is present in a much smaller amount than nitrogen, it is the most essential gas for the survival of living organisms. The first important function of oxygen is respiration. Humans, animals and most living organisms breathe oxygen to release energy from food. Without oxygen, life as we know it would not be possible. The second important function of oxygen is support combustion or burning. Oxygen itself does not burn, but it helps other substances burn. For example, a candle, a gas stove or a campfire will go out if there is no oxygen available. Oxygen is also used in hospital to help patients and breathing difficulties, and it is carried by mountaineers when they climb very high mountains where the oxygen level is low. So we can say that oxygen is essential not only for respiration but also for combustion, making it one of the most important gases in the atmosphere. Now let us discuss another permanent gas in the atmosphere, that is argon. Argon makes up about 0.93% of the Earth's atmosphere. Although its amount is much smaller than nitrogen and oxygen, it is still the third most abundant gas in the dry air. Argon is an inert gas. This means it is chemically inactive and does not easily react with other gases or substances. Because of this property, argon does not actively take part in the atmospheric reaction or weather processes. Although argon has no direct role in respiration or photosynthesis, it helps maintain the stable composition of the atmosphere. Argon is also very useful in our daily life. For example, it is used in electric bulb to protect the filament from burning quickly. It is also used in welding and some scientific and medical equipment because it does not react easily. So we can say that argon is a chemically inactive gas that remains stable in the atmosphere and has many practical applications in industry and technology. Now let us discuss carbon dioxide and carbon dioxide. Carbon dioxide makes up only about 0.04% of the Earth's atmosphere. Although its amount is very small, it is one of the most important gases in the atmosphere. The first important function of carbon dioxide is photosynthesis. Green plants absorb carbon dioxide from the atmosphere and in the presence of sunlight and water prepare their own food. During this process, plants release oxygen, which is essential for humans and animals. The second important function of carbon dioxide is that it acts as a greenhouse gas. It absorbs and traps some of the heat radiated from the Earth's surface. This helps maintain a suitable temperature for life on Earth. Without this natural greenhouse effect, the Earth would become too cold for most living organisms to survive. However, due to human activities such as burning fossil fuels, industrial emission, and deforestation, the amount of carbon dioxide in the atmosphere is increasing. As a result, more heat is trapped, leading to global warming and climate change. For example, when we burn coal, petrol, or diesel in factories and vehicles, carbon dioxide is released into the atmosphere. This increases the greenhouse effect and raises the Earth's average temperature. Can you name two human activities that increase carbon dioxide in the atmosphere? Let me know in the comment. So far, we have discussed the permanent gases of the atmosphere. Now let us learn about variable gases. Unlike permanent gases, the amount of variable gases changes from place to place and from time to time. These gases have a great influence on weather and climate. The most important variable gases is water vapor. Its amount varies depending on temperature and location. It is responsible for the formation of cloud, rainfall, fog, and many other weather phenomena. Another important variable gas is ozone. Although it is present in a very small amount, it forms the ozone layer in the stratosphere, which protects life on Earth by absorbing the sun's harmful ultraviolet rays. Methane is also another variable gas. It is released from wetland, livestock, rice field, and the decomposition of organic matter. Methane is also a greenhouse gas and contribute to global warming. Hydrogen is present only trace amount in the atmosphere. It is the lightest gas and has a very limited role in atmospheric processes. So we can say that although these gases are present in small and changing amount, they play a major role in controlling weather, climate, and the earth energy balance. Let me ask you some questions. Let me ask you a question. Can anyone name the most important variable gas responsible for rainfall? The answer is water vapor. Now let us discuss the most important variable gas in the atmosphere, that is water vapor. Water vapor is the gaseous form of water. It enters the atmosphere mainly through evaporation from ocean, rivers, lakes, and through transpiration from plants. These two processes together are known as evapotranspiration. The amount of water vapor in the atmosphere is not the same everywhere. It ranges from nearly 0% in cold polar regions and very dry desert to about 4% in hot and humid tropical regions. Water vapor is extremely important because it is responsible for cloud formation. When water vapor rises and cools, it condenses into tiny water droplets from forming clouds. These clouds later produce rainfall, snowfall, or other form of precipitation. Water vapor also absorbs and stores heat, helping to regulate the Earth's temperature. This is why areas with more moisture in the air often feel warmer and more humid. It also plays a major role in weather phenomena such as cloud, rain, fog, thunderstorm, and cyclones. For example, after a hot sunny day, water evaporates from pond, river, and ocean. As this water vapor rises into the atmosphere, it cools, forms cloud, and eventually falls back to the earth as rain. This process is called water cycle. So, although water vapor is present in a small and variable amount, it is the driving force behind the Earth's weather and the condition water cycle. Let me ask you a question. Can anyone tell me the two main processes through which water vapor enters the atmosphere? The answer is evaporation and transpiration. Now, let us discuss the third important component of the atmosphere, that is dust particles and aerosol. Dust particles and aerosol are tiny solid or liquid particles suspended in the atmosphere. Although they are microscopic and cannot usually be seen individually, they play a very important role in the atmosphere. These particles come from both natural and human-made sources. Natural sources include volcanic eruption, desert dust, sea salt, forest fire, and pollen. Human activities such as industries, vehicles, construction work, and burning of fossil fuels also release a large number of aerosol into the atmosphere. One of the most important functions of dust particles is that they act as condensation nuclei. This means water vapor condenses around these tiny particles to form cloud droplets. Without dust particles, cloud formation and rainfall would be much more difficult. Dust particles also scatter sunlight. Because of this scattering, we see beautiful red and orange color during sunrise and sunset. They also influence the Earth's climate by reflecting or absorbing solar radiation. However, when their concentration becomes too high, they reduce visibility and increase air pollution. For example, after a volcanic eruption or during a dust storm, the sky often appears hazy because of the atmosphere contains a large number of dust particles. Similarly, in polluted cities, smoke and dust reduce visibility and make the air unhealthy to breathe. So, although dust particles and aerosol are present in very small amount, they play an important role in cloud formation, weather, climate, and even the colors we observe in the sky. Can you think of a day when the sky looked hazy or the sunset appeared deep orange? What do you think caused it? The answer is dust particle and aerosol scattered sunlight, creating those beautiful colors while also affecting visibility. Now let's understand why the atmosphere is so important for life on Earth. We can think of the atmosphere as an integrated life support system because it performs many essential functions. First, it supports life by providing oxygen for humans and animals to breathe and carbon dioxide for plants to carry out photosynthesis. Second, it acts as a thermal controller. Greenhouse gases in the atmosphere trap some of the Earth's heat, keeping our planet warm enough for life. Without this natural greenhouse effect, the Earth would be too cold. Third, the atmosphere works as a radiation shield. The ozone layer absorbs most of the sun's harmful ultraviolet rays, protecting living organisms from damage. Fourth, it provides physical protection. Most meteors burn up due to friction with the atmosphere because they can reach the Earth's surface. Finally, the atmosphere is the engine of weather and climate. Water vapor and aerosol help form clouds, rainfall, wind, and other weather phenomena. So, the atmosphere not only makes life possible but also protects and maintains a suitable environment for all living organisms. Before we end, let's quickly revise the main points. The atmosphere is gaseous envelope surrounding the earth. It is made up mainly of 78% of nitrogen and 21% of oxygen along with small amount of other gases. Water vapor and dust particles play an important role in cloud formation and weather processes. Overall, the atmosphere acts as a life supporting blanket. It creates weather, regulates climate, and makes our planet suitable for life. Thanks for watching. If you found this video helpful, please like, share, and subscribe for more geography lessons. Thank you.